is now more less. So basically, the cumulative frequency would be the associated frequency plus all the frequencies that went before it. So therefore, the cumulative frequency for this particular class will be 15. Then, the cumulative frequency for this class will be the associated frequency plus all the frequencies that went before. That happens to be 25 plus 15. And 25 plus 15 happens to be 40, right? Let us look at this. This class from 31 to 40 of a frequency of 22. How are we going to get the cumulative frequency? Anyway, how will you get the cumulative frequency for this? I will add what? 22 plus plus 70. Why are we adding 70? Because all the frequencies that went before will give you some of this, and this. But we have 15 plus 25 plus 30. We already have as 70. So all we have to do is add 22 to 70. And 22 plus 70 will give me what? 92. Okay. If you were to take a look at that handout that you would recognize that the data that you have before you is the same data that is on the board. But let's see what the data is saying. Slave 4. Stop. Now you would have seen that the total amount of students in this examination is 100. And it is not by sheer coincidence that we have 100 at the end of our cumulative frequency. What that means is that it is 100 students in the sample. Now to plot the cumulative frequency curve, basically you do it just as how you would plot any normal curve. In a normal curve you would have plotted your x values first, followed by your y values. Okay? Your x value serves as your mass. In this case, because of the fact that we have a range of values that represent mass, that is from 1 to 10. So we tend to do y value. How do we get the upper boundaries? Simply by adding 0.5 to 10. So we look at 10.5. So 10.5 will be the first value we are going to use for x. And we're going to plot that against 15. So, where is 10.5? Now I'm going to tell you this. Because of the scale that we use sometimes, and I'm going to remind you of this, because of the scale that we use sometimes, it will be difficult to obtain the 10.5. Because the scale we use on the x-axis here is 1 centimeter to 5 units. That was the prescribed scale. But each one of the subdivisions that we want represent 1/5. 1/5 is 0.2. And half of 0.2 is 0.1. And half of 0.1 is 0.5. So that would be a very, very minute digital plot. So in such cases, what do? You plot the upper class limit against your cumulative frequency. And so we are going to use the upper class limit. And what is the upper class limit? I told you all to easily find it out is the maximum seen value in a class. So the upper class limit in this class will be 10 because this is the maximum value that is seen. And the lower class limit of this class is 1. What is the upper class limit of this class? 20. And what is the lower class limit? 11. What is the upper class limit of this class? 40. And what is the lower class limit? 31. So we're going to plot the 10 against 15. Because as I said, it will be inconvenient for us to plot 10.5. So 10, 15. We're going to look for 10 on the x and 15 on the y. 15 on the y, bring it way here. So this will be 110, 15. Then we are going to plot Sorry?
42.
Tell me, Manga.
4092.
4092 is correct. So we're going to look for 40 on the X, 92 on the Y. 92 would be about here. Now, your graph will be more accurate than mine. Okay? Then the last one we are going to plug is roughly 50, 100. 50, 100 would be this one here. Okay. Now, I want you to note something. The value here does not indicate where the curve cuts off. So now what do we do next? Well, we can imagine that you had a class before here. And if you had a class before here, the upper class boundary would have been 0.5. And so therefore, the upper class limit would have been 0. So 0 would have corresponded to a frequency of 0. So therefore, this would have been your maximum one. It is done freehand. That is to say, the curve is done like this. Try to ensure that you have the curve passing through the center of each one. And the curve should look like this. And this is typical of all cumulative frequency curves. Okay, but what it seems that some of you guys had an error in the reading of the graph. Okay? You need to keep in mind the scale that you are using. Now take a look at this. This has a scale of 1 centimeter to 5 units. So that means there are 5 small subdivisions between a unit, okay? 1, 2, 3, 4, 5, okay? Each one of the subdivisions is 1/5 of the entire unit. And if the entire unit is 5, each one would be 1, okay? So therefore, for this to come down here, if it's here, it's 30. One of the subdivisions will be 31, and the other one 32. Okay? So it was a problem with the reading of your unit and not necessarily your wrong graph drawn. If the interpolation was a problem. So what I'm going to do, I'm going to give you an exercise to do so that you can draw the cumulative frequency curve yourself and you can derive the values of Q1 and the values of Q3. Later on, or the next day of class, what we're going to look at is we're going to look at a value that is between Q1 and Q3, which is called Q2. And we see some resemblance with Q2 and the median. As a matter of fact, Q2 is the median. We will also look at the interquartile range and the semi-interquartile range, and I will tell you what we go about finding the quartile range and the interquartile range. But for this evening, we were able to see how to complete a cumulative frequency table. We were able to see how to draw a cumulative frequency graph, and we were able to deduce the quartiles, namely the lower quartile and the upper quartile